Good day, everyone. I am Sir Manny, your teacher in EIM 11. Our topic for this day is all about basic electricity. For your understanding, what is electricity? So before we proceed, let us answer first this question. What are the types of circuit? Anybody? Okay,
Series.
okay, very good. Yes,
Parallel.
okay, very good. So that is the uh, types of circuit. So first, we have a series circuit. So here is the pictorial diagram of series circuit. Analyze the circuit. Next, we have the parallel circuit. And here is the pictorial diagram of parallel circuit. Analyze the circuit.
Okay.
So that is the types of circuit. We have the series and parallel circuit. So let us now proceed to the parts of complete circuit. So for your understanding, what are the parts of complete circuit? So let us now proceed to the parts of complete circuit. So before we proceed, let us answer first these two questions. First, how can you say that the circuit is complete? Second, what are the parts of complete circuit? So in this lecture, we will answer the two questions. So in order that electricity can be better understood, different parts or components of complete circuit must be known well. First, the electrical circuit should have a source of power where the electric current starts to flow.
No.
The power source can be a generator, storage cell, one or more cells. So here's the picture of generator and the cells or the so-called battery. Second, a path such as electrical wires is needed in order that electricity from the source can be transmitted. So we use a color-coded wire. The color is red and black to identify the positive and the negative side, or the live area and the neutral area, or the ground area. Third, there should be a current consuming device or appliance that will consume or use electricity. Our commonly used consuming device is a bulb. And lastly, a control or switch that will cut off the flow of current when the appliance will not be in use. So the switch is used to control the flow of current. It will use to turn on and off. All the requirements mentioned are important in order to have complete electrical circuit. So if one is missing, you cannot say that that is a complete circuit. So here's the complete circuit diagram. So composed of source of power or the generator or cell or battery. We have electrical path or the wire. We have the current consuming device or the bulb, and we have the switch. So absence of one will not make a complete circuit. So let us now proceed to the types of circuit. So first, we have a series circuit. In a series circuit, many bulbs are wired one after other so that when one of the bulb is busted, all will not light up. So it means the series circuits, the connection must be in a one loop. The reason is that the current cannot pass through the bulb because of the filament is cut. So there is no continuity for current in order to go back to the power source. So here's the diagram of series circuit, two bulbs connected in series. So here's the pictorial diagram of series circuit, three bulbs connected in series. Next type of circuit, we have the parallel circuit. This is the circuit whereby two or more bulbs are wired with each bulb having its own circuit. So it means in parallel circuit, we have two loops or two or more loops used in parallel circuit. So this means that if one is busted, the other bulb will still light up because current passes separately in each circuit. In a parallel circuit, the electric current flows and only a part of the total current in the circuit goes through each bulb. So each bulb has a circuit of its own with the battery. So the electric current flowing through each bulb moves in the different path in the circuit. So it means they have their own loops in parallel circuit. So here's the parallel circuit, three bulbs connected in parallel. So here's the pictorial diagram of parallel circuit, three bulbs connected in parallel. Let us now proceed to the laws of a parallel circuit. The voltage is the same across each branch. So as you can see in this illustration, the circuit are the same voltage across each line. The total current is the sum of all the current in each circuit. So as you can see in this illustration, we have two loads, but we have in different loads. So they have different in resistance. The total resistance is less or approximately equal to the smallest resistive. So as you can see in this illustration, we have two different loads, 30 ohms and 10 ohms. As you can see, in 10 ohms, the travel of voltage is faster than 30 ohms. So it means the higher the resistance, the travel of voltage is lower. The lower the resistance, the travel of voltage is higher. So let's proceed to the difference between series and parallel circuit. So I have two illustrations here. Illustration 1, we have the series, and illustration 2, we have the parallel. So as we can see, as I can say earlier, the series is connected in one loop. The parallel is connected in two or more loops. As you can see the illustration 1 in series, we have two bulbs connected in series, but the other bulb is busted. As you can see, the other bulb will not light up because they have no continuity. They have a cut on a circuit. And illustration 2, we have two bulbs connected in parallel. Same, one bulb is busted, but the other bulb is still lighting up because they have their own loop. I have here a video presentation about series and parallel circuit to be better understand what is series circuit and a parallel circuit. So here's a simple video presentation.
Spiky and Bubbles were playing with the ball when it hit the chandelier and the string of decoration lights. Something interesting happened next.
Oops, this is bad. We should have gone outside to play. Hey Bubbles, isn't this strange? Only one bulb of the chandelier has gone out. But for the decoration lights, all the bulbs have stopped working. But why?
Good question. It's time to learn about the types of circuits. An electric circuit is a path along which electric current flows. A simple circuit has a cell, a bulb, and a switch connected by wires. But what happens when there are two bulbs? How can we connect them?
Well, we can connect the second bulb right next to the first bulb.
Or we can connect it above the first one.
Well, let's see who's right. Let's make Spiky's circuit first. We need a battery, a switch, 3 bulbs, 2 that work and 1 that's burnt out, and connecting wires. Let's set up the circuit. Now, let's add another bulb right next to the first one. What happens to the brightness of the first bulb?
Whoa, it's dimmer.
Exactly. Now replace one of the light bulbs with a burned out one. What happens?
Both the bulbs go out.
This is a series circuit. If all the electrical components are connected one after another in a single loop, then it is a series circuit. In a series circuit, there is only one path for the current to flow. The amount of current that flows through each bulb of the circuit is the same. Now let's try Bubbles' suggestion. We'll add another bulb above the first one. What happens to the brightness of the first bulb?
It remains the same this way.
Correct. Now replace one of the light bulbs with the burned out one. What happens?
The burnt out bulb does not glow, but the other bulb is still glowing. It is not affected.
Excellent observation. This is a parallel circuit. If all the electrical components are connected in 2 or more loops, then it is a parallel circuit. In a parallel circuit, there is more than one path for the current to flow. Each loop is independent, so the current in one loop will not affect the current in another loop. So, now we know that both Spiky and Bubbles were right. Spiky connected the bulbs in a series, whereas Bubbles connected the bulbs in parallel. Hence, there are 2 types of circuits. 1. Series circuits, for example, decoration lights. 2. Parallel circuits. Our home appliances are always connected in parallel.
But why? Why don't we use series circuits in our home?
Because series circuits come with a disadvantage. Let's take a closer look with an example. Look at these bridges. They are connected one after another in series. You can cross these bridges easily. But what happens when one of the bridges collapses? Can you cross to the other side?
No, we can't.
Exactly. This is the disadvantage of a series circuit. A break in any part of the circuit stops the flow of current in the whole circuit. Another disadvantage is that the more bulbs we add to the series circuit, the dimmer they become. Now look at these bridges connected in parallel. What happens when one of the bridges collapses? Can you cross to the other side now?
Yes, because we can use the other bridge to cross to the other side.
Well done! This is the advantage of a parallel circuit. When there is a break in one of the branches in the circuit, current can still flow through the other branches. Also, the brightness of the bulbs remains the same since every loop is independent. Now, can you explain the chandelier and decoration lights problem you had earlier?
Oh yes, it makes sense now. Only one bulb of the chandelier went out because it is connected in a parallel circuit. One broken bulb did not affect the current in rest of the bulbs. But for the string of lights, all the bulbs went out because it is connected in series. One broken bulb will stop the flow of current to all the bulbs.
Good job! Let's summarize. There are two types of electric circuits. A series circuit is one in which all the electrical components are connected one after another in a single loop. A parallel circuit is one in which all the electrical components are connected in two or more loops. A disadvantage of the series circuit is that a break in any part of the circuit stops the flow of current in the entire circuit, but a break in any part of the parallel circuit does not.
So I have here 3 questions to be answered. First, what are the difference between series and parallel? Second, why do we need to understand basic circuit? Third, how can you say that the circuit is complete?